Hello everyone, my name is Jonathan Freiberger, and this is my presentation for System Security 2 ISA 4220 regarding Imap and DNS, information and hardening recommendations for each. So what is Imap? Imap stands for Internet Message Protocol. It typically operates on port 143. However, if you're using IMAPs, you will be using port 993 paired with secure socket layers. IMAP typically uses TCP/IP, and it is used to retrieve mail from a server. While IMAP and POP3 serve similar purposes, they work very different from one another. Unlike POP3, IMAP does not delete any mail from the server once it has been retrieved by the client. The client doesn't even download the messages like it does in POP3. On top of this, IMAP works with multiple clients, unlike POP3, where it's meant ideally for only a single client. Especially in today's atmosphere of multiple computers and smartphones, having IMAP allows users to sync those mail inboxes among those many devices rather than being limited to only a single one device. It also allows users to manipulate the mail without needing to download it first. Reading, organizing, and sorting can all be done without downloading every mail message, without downloading every attachment. So how do we harden IMAP? To start, IMAP should be enforced so that it uses port 993. This encrypts the connection and ensures that the transmission isn't being sent in clear text. Usernames and passwords won't be visible to anyone who gains access to those. Then, businesses will want to maintain a local IP blacklist and also check DNS-based blacklists. Doing both of these will prevent spam mail and potential phishing attacks by going ahead and blocking mail from known bad IPs and domains. Lastly, configuring the mail relay. This just prevents attackers from spamming mail servers, the user mail servers. Moving on to DNS, what is DNS? So DNS stands for Domain Naming System, and what it does is it translates the name that we enter into a web browser to an IP address. So if we enter in a domain such as google.com, it then takes that domain name and translates it into an IP address that the computer can actually use to route us to where we want to go. Now, the standard operating port for DNS is number 53, and it actually uses TCP as well as UDP for different functions. Continuing on DNS, there's 3 levels to the domains in the domain naming system. There's the top level, which is the very last part of the domain name. So examples of these are going to be .com, .edu, .gov, .net, signifying typically what type of business or organization the domain is part of, such as governments or education. Preceding the top level domain is the second level domain. And this is going to be what we often see as the company name, such as Amazon, Google, or even in our school's case, Kennesaw. And then lastly is the subdomains. Now, a domain name can have multiple subdomains, each moving a further level down, but a subdomain is what precedes the second level domain. So an example that we've used in school before would be seclab2.kennesaw.edu. That seclab2 is the subdomain, which routes to a different part of the second level domain. Even more on DNS. DNS works on a series of requests, and once a request is made, a query, it moves through a series of servers before it's completely processed. It begins by going to a recursive resolver, and this responds to requests from clients and locates the DNS record. The resolver will go through the name servers until it has every part of the domain that is looking to be accessed. It first goes to the DNS root, which responds with the top level domain. The DNS TLD, which responds to the resolver with the IP of the domain. And then lastly, it goes to the authoritative. And there can be multiple layers of authoritative based upon subdomains. But it makes up the last portion of the chain, and it actually contains the DNS resource records. Now for hardening DNS, there's a couple of things we want to do. We want to disable DNS recursion. This prevents DNS poisoning or spoofing, which allows an attacker to redirect web traffic to a domain name that isn't the intended recipient. So rather than going directly to Google, they'll go to a mock domain that is often used for phishing purposes. Restrict zone transfers. This will prevent attackers from gaining an understanding of the network layout and seeing exactly how the network is planned. You'll want to use a non-root account for bind, as it limits the usefulness of the account if it were to be breached. Lastly, you would want to only allow secure connections to DNS. That completes my presentation. Thank you very much for watching. Goodbye.